The National Aeronautics and Space Administration's Double Asteroid Redirection Test, or DART, spacecraft successfully impacted its target asteroid, Dimorphos, on September 26, 2022. This occurred at 7:14 p.m. Eastern Daylight Time, which translates to 23:14 Coordinated Universal Time. The primary goal of the DART mission was to evaluate the practicality of using a kinetic impactor to alter the course of an asteroid that might pose a threat to Earth. The DART spacecraft was engineered to collide with Dimorphos at a velocity of roughly 6.6 kilometers per second, equivalent to 4.1 miles per second. The anticipated outcome of this impact was the formation of a crater on the surface of Dimorphos, accompanied by the ejection of a considerable quantity of material into space. This ejected material was projected to generate an extensive plume of dust and debris, potentially observable from telescopes situated on Earth. However, the degree to which the impact plume would be visible from Earth remained uncertain. It was expected that the plume would be most discernible in the hours immediately following the impact, but accurately predicting its brightness and duration proved challenging. The plume's visibility was also subject to factors such as prevailing weather conditions and the observer's geographical location. If one were able to witness the impact plume, it would likely have manifested as a distinct point of light in the night sky. The plume would have reached its highest altitude in the sky shortly after the moment of impact and would have gradually diminished in intensity over time. The optimal viewing conditions for the plume would have been in regions characterized by clear and dark skies. Even if direct observation of the impact plume was not possible, additional information about the DART mission can be accessed through NASA's official website. Kinetic impact is a technique used to alter the trajectory of an object in space, typically an asteroid or comet, by colliding a spacecraft with it. The basic principle behind kinetic impact is the transfer of momentum. When the spacecraft collides with the target object, it imparts some of its momentum to the object. This changes the object's velocity and, consequently, its trajectory. The amount of momentum transferred depends on the mass and velocity of the spacecraft, as well as the mass of the target object. The change in velocity of the target object is typically very small, but over time, this small change can add up to a significant difference in its trajectory. There are several factors that need to be considered when planning a kinetic impact mission. Firstly, the mass and velocity of the spacecraft need to be carefully chosen to ensure that the impact will be effective in changing the target object's trajectory. Secondly, the timing of the impact is also crucial. The impact needs to occur at a specific point in the target object's orbit in order to achieve the desired change in trajectory. Thirdly, the composition and structure of the target object need to be taken into account. If the target object is very fragile or loosely held together, the impact may simply break it apart rather than change its trajectory. Kinetic impact is a promising technique for planetary defense, but it is not without its challenges. Firstly, it requires a long lead time. It can take many years to develop and launch a spacecraft to intercept a potentially hazardous object. Secondly, the accuracy of the impact needs to be very high. Even a small error in the impact location can result in a much different change in trajectory than expected. Thirdly, there is a risk of unintended consequences. The impact could potentially break the target object into smaller pieces, which could then pose a threat to Earth. Despite these challenges, kinetic impact remains one of the most promising techniques for deflecting potentially hazardous objects. Further research and development are needed to improve the effectiveness and reliability of this technique. The DART mission was specifically designed to test the kinetic impact method of asteroid deflection. The target asteroid, Dimorphos, is a small moon orbiting the larger asteroid Didymos. Neither asteroid poses a threat to Earth. The DART spacecraft impacted Dimorphos at a speed of approximately 6.6 kilometers per second, equivalent to 4.1 miles per second. The impact was expected to change Dimorphos' orbital period around Didymos by a small amount. Scientists are still analyzing the data from the DART mission to determine the precise change in Dimorphos' orbital period. The results of the DART mission will help to inform future planetary defense efforts. Asteroids and comets are remnants from the formation of our solar system about 4.6 billion years ago. They are rocky, metallic, or icy bodies that orbit the Sun. Asteroids are mostly found in the asteroid belt, which lies between the orbits of Mars and Jupiter. Comets are mostly found in the outer solar system, in the Kuiper belt and the Oort cloud. Both asteroids and comets can pose a threat to Earth. If a large asteroid or comet were to collide with Earth, it could cause widespread damage and even a mass extinction. Scientists estimate that there are millions of asteroids and comets in our solar system, but only a small fraction of them have been identified and tracked. NASA and other space agencies are working to identify and track potentially hazardous objects or foes. A PHO is an asteroid or comet that is large enough and close enough to Earth to pose a significant threat of impact. There are several techniques that could be used to deflect a PHO, including kinetic impact, gravity tractor, and nuclear detonation. Kinetic impact involves colliding a spacecraft with the PHO to change its trajectory. Gravity tractor involves using the gravity of a spacecraft to slowly pull the PHO off course. Nuclear detonation involves detonating a nuclear device near the PHO to vaporize part of it and change its trajectory. The DART mission is an important step in developing and testing planetary defense technologies. The mission will help to determine the effectiveness of kinetic impact as a method of asteroid deflection. The results of the DART mission will also help to inform future planetary defense efforts. Here are some additional details about the DART mission. Firstly, the DART spacecraft was about the size of a vending machine and weighed about 600 kilograms. Secondly, the DART spacecraft was equipped with a single instrument, the Didymos Reconnaissance and Asteroid Camera for Optical Navigation, or DRACO. And thirdly, the DART mission cost about $300 million. The European Space Agency, ESA, is planning a follow-up mission to DART called Hera. Hera will launch in 2024 and will arrive at Didymos and Dimorphos in 2027. Hera will study the crater created by the DART impact and will also measure the mass and composition of Dimorphos. The Hera mission will provide valuable information about the effectiveness of kinetic impact as a method of asteroid deflection. The study of asteroids and comets is important for several reasons. Firstly, they are remnants from the formation of our solar system and can provide clues about the early history of our solar system. Secondly, they can pose a threat to Earth. And thirdly, they may contain valuable resources. Asteroids and comets are made up of a variety of materials, including rock, metal, and ice. Some asteroids and comets may contain valuable resources such as water, minerals, and precious metals. In the future, it may be possible to mine asteroids and comets for these resources. There are several ways to learn more about asteroids and comets. Firstly, you can visit the websites of NASA and other space agencies. Secondly, you can read books and articles about asteroids and comets. And thirdly, you can visit a museum or planetarium. The DART mission was a success, but it is important to remember that it was just one step in the process of developing and testing planetary defense technologies. More research and development are needed to improve the effectiveness and reliability of these technologies. In addition to kinetic impact, there are other techniques that could be used to deflect a PHO, including gravity tractor and nuclear detonation. Each technique has its own advantages and disadvantages. Gravity tractor is a slow but precise method of deflecting a PHO. It involves using the gravity of a spacecraft to slowly pull the PHO off course. Nuclear detonation is a fast but risky method of deflecting a PHO. It involves detonating a nuclear device near the PHO to vaporize part of it and change its trajectory. The best method of deflecting a PHO will depend on the size, composition, and trajectory of the PHO. It is important to have a variety of tools available to deal with different types of threats. The DART mission has shown that kinetic impact is a viable method of asteroid deflection. This is an important step forward in protecting our planet from potentially hazardous objects. The success of the DART mission highlights the importance of international collaboration in planetary defense. NASA worked with other space agencies and organizations around the world to make the DART mission a success. The European Space Agency, ESA, is planning a follow-up mission to DART called Hera. Hera will launch in 2024 and will arrive at Didymos and Dimorphos in 2027. Hera will study the crater created by the DART impact and will also measure the mass and composition of Dimorphos. The HERA mission will provide valuable information about the effectiveness of kinetic impact as a method of asteroid deflection. The DART mission and the HERA mission are both important steps in protecting our planet from potentially hazardous objects. By working together, we can develop the technologies and strategies needed to defend ourselves from the threat of asteroid impact. It is also important to raise public awareness of the threat of asteroid impact. Many people are not aware that asteroids can pose a threat to Earth. By educating the public about the risks, we can encourage them to support efforts to develop and deploy planetary defense technologies. The DART mission was a great success, but it is important to remember that the work is not done. We must continue to invest in planetary defense research and development to protect our planet from the threat of asteroid impact. The DART mission provides valuable data and insights that will inform future planetary defense strategies. As we continue to explore space and learn more about the universe around us, we must also be vigilant in protecting our planet from potential threats. The DART mission is a testament to human ingenuity and our commitment to protecting our planet. It is an inspiring example of what we can achieve when we work together to solve global challenges. The DART mission was a remarkable achievement that demonstrated the potential of kinetic impact as a viable method for asteroid deflection. The mission's success underscores the importance of continued investment in planetary defense research and development. By working together, we can enhance our understanding of asteroids and comets, develop effective mitigation strategies, and safeguard our planet from potential impact threats. The knowledge gained from the DART mission will undoubtedly play a crucial role in shaping future planetary defense efforts and ensuring the long-term safety of Earth. It is essential to remain proactive in addressing the risks posed by near-Earth objects and to continue exploring innovative approaches to planetary defense. The DART mission serves as a reminder that international collaboration and scientific advancements are vital in protecting our planet from potential cosmic hazards. By fostering a global commitment to planetary defense, we can collectively mitigate the risks associated with asteroid impacts and safeguard the future of humanity. The DART mission has not only advanced our technological capabilities but has also fostered a greater appreciation for the importance of planetary defense. It is crucial to maintain this momentum and to continue investing in research, development, and international collaboration to ensure the long-term safety of our planet.